developers, and welcome to a new open class number 150, which is quite a lot, let me say this. And today we are going to be talking about ROS2, more specifically about ROS2 navigation, and more specifically about the Simple Commander, which is an API that you can use very conveniently for interfacing and for creating programs which use the NavigateToPose system in order to command a robot and to navigate a robot autonomously. So yeah, welcome everybody to this new open class. And then let me know, as always, in the comments, first of all, if everything is fine, sound is fine, image is fine, so that we can continue without any problems. Then from my side, yeah, so I'm going to get started already. So let me right now share here my computer screen. And I'm going to, let me first of all come here to the live open class so that I can make sure that everything is fine. All right, image seems to be okay. Arnold says that I am very soft. Okay, let me check here the sound configuration. It's looking pretty good here. Maybe you can turn your volume a little bit higher here. Arnold, maybe that makes it better. Because here, yeah, so I have it pretty high. I can still increase it a little bit, but maybe that's going to be too much. All right. Hello there. Okay. I don't know if it's this one or it's this one. No. Okay. Okay, I can see that Ricardo says, we can hear you well. Okay, perfect. And Arnaud is working on it. All right, then the setup seems okay, so let's get started. Then, as always, the first thing to do is to get the class rosject. And in case that you are new to this open class, the way to do this, it's very, very simple. So you just have to click on this button that you have here right above the chat, which says fork and open the class rosject. So I'm going to click here myself. And what this button is going to do is to, first of all, it's going to create a copy of today's rosject into your account. All right, so you are going to have a copy of this rosject in your account forever. Yeah, so you are going to be able to launch it whenever you want. You can keep working on this rosject if you want next week, next month, but you are going to have it there forever for in case that you want to revisit it, review it at any moment. This is the first thing, and then also, as you can see, it automatically redirects you to the rosject page. And you can see here at the right side, you are going to have the streaming area with the live stream here, so that you can see and see me and hear to what I am saying. And of course, the chat, so that we can keep here a communication between us. So this is an interactive class. The goal of this class is that everything that I'm going to be explaining, but especially everything that I'm going to be doing during today's class, you can reproduce it yourself. This is the purpose of sharing with you the rosject, so that you can reproduce and try yourself all the steps that I'm going to be doing here. Yeah, so this is going to be a practical class, as always, and the goal is that you can try it yourself and reproduce the steps that I'm going to be doing. And of course, in case that you have any doubts, that you have any comments, issues, problems, so you have the chat to write it down, and this way you can let me know that you are having some problems, you are stuck, something is not working for you, so that we can try to figure out and solve the issue. Yeah, so first step for me, it's done. Okay, first step is to get a copy of the rosject and open it. So once it finishes loading, you should get here the notebook opened. The notebook, as you can see, make sure that you have the correct one. So it should be for the class number 150. And basically the notebook contains all the theory and all the instructions, codes, commands that we are going to be using and executing during today's class. All right, so you have here all the steps that I'm going to be doing. So in case that you get lost at some point, or that you want to check it and do it later at your own pace, you have all the steps here explained and defined. All right. So yeah, let me know please in the chat if you have loaded your rosject so that we can keep moving all together. So have you been able to get a copy of the rosject, and did it load properly? Zoltan is saying loaded. Also Arnoud, Andres, loaded correctly. Also Patricia, show. Okay, perfect. Then we are ready to get actually started. So the very first thing that we are going to do is to start a simulation. Yeah. So first of all, of course, we are going to be working with navigation too. So the simulation is going to be based in ROS2. Specifically, this rosject, if you click here on the name down here, you will see the ROS distribution that we are using, which is in this case ROS2 Galactic. Okay, so the first thing is to start the simulation. So in order to start the simulation, I have prepared this bash script that you can directly execute, and it's going to start the simulation. So in order to execute this command that you have here in the notebook, the first thing that you need to do is to, of course, have a shell, a terminal. So in order to open a new terminal, you have to click on this icon that you have here shown in the notebook's image, which you have here in the bottom bar. It's the first one, starting from the bottom left area. It's this one, which says web shell. So you can click directly here in this button, and this is going to open, as you can see, a new empty shell. There you go. Yeah, this is a regular Linux Unix shell where you can type regular commands. And in this case, we are going to execute this command. So what you can do, what I suggest, what I recommend you to do, is to copy the command directly here from the notebook. So you can copy it directly from here and then just paste it here into the terminal. Yeah, this is going to speed things up so that you don't have to type all the commands character by character. Okay? Then, yeah, so let me execute this command myself. And I can show you now in a moment what this script contains, but you will see it's very simple. It's just setting some environment variables and then launching a simulation using ROS2. So here it's starting to load everything, as you can see. Don't worry if you see some red messages, okay, or even yellow messages. Okay, don't worry, it's normal. So yeah, then after some seconds, the first time that you load the simulation, it usually takes longer than normal, because Gazebo is downloading models and this kind of stuff, which take some extra time. So, so yeah, it might take a little bit longer, and even it might fail, which is my case, okay? So let me come back here. Here you can see that I have this error message of GC server which has crashed, okay? So this happens sometimes the first time that you launch the simulation, and from the tests I have been doing, I suspect that this might be because of the low CPU capacity of these computers that we are using, okay? So the simulation that we are going to run, you can see an image here. It's a quite big simulation, quite big environment. It's this warehouse environment. And then sometimes it might happen that in these specific instances, the first time that you launch the simulation, it crashes. GC server crashes. All right? then don't worry, okay? Don't worry. If your gazebo simulation crashes, you are going to see that here in your gazebo client, it's going to look like this. It's going to get stuck here, trying to load gazebo, but it's never going to load. Yeah. So if this is your case, it might happen also perfectly that your simulation has loaded properly. Yeah. So for some of you, probably the simulation has loaded without any issues. Usually when there are problems like this, they always happen to me. But for the attendance, usually everything is working all right. Then, okay, in any case, if this is your case, if your simulation has also crashed like this, don't worry. All you have to do is to come here to the shell and press Control-C, okay? So you stop the command, and then you just relaunch it. Yeah, you just launch it again. And then this second time, it should work properly, and the simulation should load properly, okay? So we will see it in a moment here. Here it's starting to load. And there you go. Okay, so now the simulation has loaded perfectly without any problems, and you can see here our warehouse environment with the robot here. It is a Neobotix MP400. It's the model, if I'm not wrong. So yeah, this is the first step. So please, all of you, reproduce the same steps that I have been doing in order to load the simulation. And please let me know. Let me know if you have been able to load the simulation properly. Are you having any issues loading the simulation? Yes, no? As I have said previously, don't worry about these red messages that you get here, okay? You can just ignore them. Simulation is done, simulation loaded. Okay, perfect. Let me get some hydration. Yeah, the simulation load opened, but it seems it works very slowly. Yeah, this is normal. This is normal. So yeah, as I was saying a moment ago, this simulation it's pretty big. Okay, so it's going to be a little bit slow. Okay, even it might cause some problems with navigation. We will see later. Okay. But yeah, ideally we should have used it. I should have used smaller simulation for this demo, but I didn't have time to prepare everything and to optimize the simulation, so I ended up using this one. But yeah, as I was saying, the computers that we are using here for the open classes are let's say that they are small in terms of resources. Yeah, they are not very powerful computers. So whenever we use big simulations, and later we are going to be loading the navigation to the system, plus RVs, plus all these things, yeah, so they basically consume a lot of resources, and then some things are going to be slow and this kind of stuff. Okay, but yeah, it is what it is. So if you want, on your time, you can try to optimize the simulation so that it doesn't consume so much resources and so on. Yeah. Okay. So other than that, of speed issues, everything is working okay, then we are ready to continue. All right, then, okay. So for today's open class, I have added here as a requirement the ROS2 navigation galactic course, because the topic that we are going to be covering now, it requires that you have a basic knowledge on ROS2 navigation, okay? Because in order for us to use the Simple Commander, we have to first, this is mandatory, we have to first have a navigation to system that is working properly. Yeah? If we don't have a navigation to system that is working properly, we are not going to be able to use the Simple Commander. Yeah? It is a requirement. Why? Because the Simple Commander communicates with the navigation to system. Okay, so of course, if we don't have the navigation to system, the Simple Commander API makes no sense. All right, this is why I have added here our ROS2 navigation course, which is based on Galactic, and where you can find, I left a link here also, where you can find basically all the basic concepts of ROS2 navigation explained here, including mapping, localization, path planning, cost maps, controller server, etc. Okay, so everything is in this course. So if you are interested, you can have a look. Then let's keep going. All right. Patricia says, finally loaded on the third attempt. Okay, okay. Great, Patricia. All right, then, yeah, so what I was saying, in order to be able to use the Simple Commander API module, we have to, first of all, have a navigation to system that is working, okay? In this case, for this class, I already provide this to you, okay? So it's now moment to open the code editor. The code editor is the second icon that you have here at the side of the shell icon, yeah, this one here. So if you click here, this is going to load the code editor or IDE, however you prefer to call it. But basically, this is going to provide us a graphical interface where we are going to be able to visualize all the folders, workspaces in this case, that this rosject contains, okay? So for this class, we are going to focus on the ROS2 workspace, which is the one we are interested in. So the ROS2 workspace is the workspace that contains all the ROS2 packages, yeah? Then inside this workspace, you are going to see that you already have some packages, yeah? So you have the T3 Foxy and Neobotix ROS2 packages, or this is a meta package, better said. So these two are related to the simulation, yeah? For instance, very quickly, if you go inside the Neobotix ROS2, you are going to find here the script that we have executed in order to start the simulation. This start warehouse Neobotix CMSH, yeah? Then if you double click here, you are going to see the contents of this script. Yeah, so this is basically what we have executed. As you can see, we are sourcing some paths, setting some environment variables for gazebo, and then finally we are running our ROS2 launch command to start the simulation. Yeah. Then besides these two, we also have a package which is named AWS Simulations. This package contains the world, this warehouse world. Okay, it contains all the models and everything related to this world. And then finally, you have this Nav2 packages folder. Okay, then if you open this folder, you are going to find here all the navigation to related packages. So we have the map server, localization server, and the path planner server. Okay, all these packages, I have already placed them here for you, and they are already configured and prepared so that you can directly use navigation too. Okay? If you don't have this for your robot and you want to use the Simple Commander API, then you are going to have to build yourself all the navigation to systems for your robot. Okay? This is important that you keep this in mind. All right. Then, yeah, so we have this setup step that we can skip it for now. We will address it later. So let me just, I'm going to remove it, not this, but the setup, because it's already down. All right. Then, in order to start the navigation to system for our robot, we have to execute this command. All right? Then what we are going to do is to leave this shell opened and running here. This is the shell where we are running our simulation, so we don't want to stop it or close it. So we are going to open a new shell. We are going to create a new one. You can do this by clicking on this add or plus button here. And this is going to open a second new terminal. Okay? Then here we are going to, let's source first of all our ROS2 workspace. Okay? Let's source our ROS2 workspace, which contains the Navigation2 packages, and then we are going to run this command. Okay, again, I'm going to copy directly from the notebook, Control-C with the shortcut, and then I'm going to paste it here into the shell. Okay? And finally, I'm going to run it. There we go. Okay, so here, all the Navigation2 systems and nodes are getting started, and as you can see, another window opens here automatically. Yeah, this one contains RVs. Okay? Yeah, so my Navigation2 nodes have finished loading, and as you can see, it has automatically opened also an RVs screen. Okay? So, sorry. Now, in order to test that my Navigation2 system is indeed working properly, I'm going to test it very quickly using RVs. So the first thing that I can see is that my robot is not properly localized in the map, right? So let me get a better picture here of the map, which is like this, okay? Then this is my map, and this is my gazebo simulation. Let me rotate this so that they are more or less matching. There we go. Okay. Oops. All right. All right. More or less, there we go. Okay. So this is the upper view from our warehouse environment in the simulation, and here it's my upper view from RVs. Yeah. So if I check RVs, it says that my robot is more or less here in the center of the room of the warehouse. But if I check the robot in my gazebo simulation, it's not here in the center, but actually it's here. Yeah, in this space here between this shelf and this one. It's here inside. So in my map, this is more or less around here. Okay? So the first thing I'm going to do is to properly localize my robot. I'm going to use, in this case, the 2D pose estimate tool from RVs to do so. So I'm going to click in the 2D pose estimate tool, and I'm going to localize my robot around here, more or less. Okay? It doesn't have to be perfect, but yeah, so now it's much better. If we compare RVs with real simulation, yeah, it's much more close one to another, right? So, okay, now that I have my robot properly localized, what I'm going to do is to send a goal to it. So let me use for this the 2D goal pose tool from RVs. Yeah, it's this one here. Then I'm going to click here and set a goal in the map. For instance, let me send my robot around here to the center of the environment, more or less. Okay, so the path is generated and my robot starts going towards the goal. Yeah, I can see this in RVs, but if I move to the gazebo simulation, I can see also that my robot is moving towards the goal. Okay? What does this mean? Well, basically this means that my Navigation2 system is working properly. Okay? After some seconds, we should see that the robot reaches the goal position. Yeah, we should see a message here indicating that the goal has been reached. Yeah, here it is. Goal succeeded. All right? Okay, so I have launched my Navigation2 system, and I have tested that my Navigation2 system is working properly. Yeah, I can send goals to my robot, and it works. So the robot is going to follow this goal until it reaches the goal position, right? Yeah? Have you been able to reproduce this? Have you been able to test the navigation-to system yourself and send a goal to the robot? Yes, no? Yes, says Zoltan. Perfect. Okay, so the first step, Patricia Shaw says also yes, perfect. Then the first step is done, yeah? The first step, as I was saying, is a requirement for using the Simple Commander API. And this requirement, is that we have a navigation-to system properly configured and working for our robot. So we have just seen that this is our case. So we fulfill the first requirement. Then this means that we are able and we can use the Simple Commander API. Okay? Then, now, in order to use the Simple Commander, we are going to install it. Okay? In this computer, in this rosject, the Simple Commander package is not installed. So we need to install it. Then let's open a third shell. Okay? I'm going to open a new shell. And in this third shell, I'm going to run the commands sudo apt update, first of all, and then I'm going to install the Simple Commander package with the command sudo apt install ROS galactic Nav2 Simple Commander. Okay? So let me again copy the command from the notebook, and as soon as the update finishes, I'm going to execute it. Yeah, so this is almost done. There we go. So now I'm going to run the install command in order to install the Simple Commander. There we go. So in this case, as you can see, it's not really installing it, but it's upgrading it. Yeah. So the package, it actually is installed in this computer, in this specific computer, but it's just upgrading it, okay? In any case, I wanted to add this command here so that you keep in mind this, okay? So you need to install this package in case that you want to use Simple Commander API in your local computer, wherever, you have to install this package, okay? Then let's just wait until it finishes. Okay, there we go. It has finished upgrading, so we are ready to start using it. Perfect. Then, so what really is the Simple Commander API? So basically, as the name itself says, it's a kind of API which provides a set of methods to interact with the navigation-to system, to interact through Python 3 more specifically. Yeah? So by using the Simple Commander API, we are going to have access to a set of methods that we can use in order to interact and to perform different actions which are related with the navigation-to system. Okay? So, summarizing, you can think of the Simple Commander as a Python API that allows you to easily interact with the navigation-to stack, navigation-to system. Okay? It provides many options, which include, for instance, the go-to-pose, go-through poses, follow waypoints. Okay? But for this class, we are going to see only the NavigateToPose. Okay? Then the NavigateToPose, it is used, as the name itself says, it's pretty self-explanatory, to make the robot navigate to a pose. Yeah, so it's very similar to what we have just done through RVs a moment ago. Yeah, a moment ago we set a goal using RVs, using the 2D goal pose on the map in order to make the robot navigate to that goal, right? So the NavigateToPose action from the Simple Commander, it's pretty similar, but it provides some extra things. Okay, we will see all this in a moment. Then this NavigateToPose is an action. Okay, so this is an action. In fact, right now we can run a ROS2 action list command. Okay, this is not in the notebook, I am improvising. Okay, but you can run right here a ROS2 action list command. This is the command you set in order to list actions in ROS2. And we are going to see here an action which is named NavigateToPose. Okay? This is the action that we are going to use. All right? This is the action that we are going to use with the Simple Commander API. Okay? Then this action uses a specific action interface, which is shown here. Yeah? As you might already know, if you are familiar with ROS2 or with ROS even, each action has an interface associated with it. Yeah? And in this interface, we define the goal, the result, and the feedback of the action, right? So actually, we can do a ROS2 action info of NavigateToPose in order to get some extra data about this action. So it's NavigateToPose. ROS2 action info NavigateToPose. I want to get some information related to this action. Okay, so here I can see the action name, clients, and servers. I cannot see the interface, maybe adding a verbose, probably like this. I don't remember exactly the command. Okay, in any case, just keep in mind that the action associated to this NavigateToPose, the action interface, the interface associated to this NavigateToPose action, it's this one. Yeah? And it has this structure. Okay? So in the goal, we are providing a pose, of course, the goal pose, and a behavior tree. Okay, you can provide your own behavior tree if you have one. If not, it's going to use the default one. Then as a result, I'm going to receive an empty message. And then as feedback, I have all this data. Okay, so as a feedback, I'm going to get the current pose of the robot, the navigation time, how much time I have been navigating, the estimated time remaining, how much time is left until I reach the goal, number of recovery behaviors that have been executed while reaching this goal, and the distance remaining to the goal. Okay? So I have many information that I can access in order to have feedback of how the robot is doing, yeah? How is going this action of navigating to a specific pose. Yeah, so this is very interesting and it can be very useful and use it in many different ways. All right. Then let's actually go to practice. Okay. So I have already introduced the Simple Commander API and the NavigateToPose action, which we are going to be using in this example, in today's example. Okay. Then let's actually create a demo. Okay. So how can we use the Simple Commander in order to use this NavigateToPose action? All right. So at this point, we are going to start by creating a package. Yeah? So we are going to create a new ROS2 package of Python type, and named Nav2 new features with some dependencies that we are specifying here. All right. Then here in this shell, let's go to the ROS2 workspace. And let's go inside the src folder, yeah? Remember that always that you create a package, it has to be inside the src folder of the workspace. Okay, very important. Then once I am inside the src folder, I can run this command in order to create a new package. Let's run it. And as you can see, a new package has been created. Nav2 new features. Also, we can see the package here through the IDE. If we come to the code editor, you are going to see that a new package has been created here. Nav2 new features, right? Then, inside this package, we are going to create a new folder named scripts, okay? So you can do this through the IDE, for instance, by right-clicking on the package and clicking now on the new folder option, yeah? And now you can set the folder name. In this case, it's scripts, okay? And this is going to create inside my Nav2 new features package a new folder named scripts. All right? And then finally, inside the scripts folder, I'm going to create a new Python script named NavigateToPose.py. Okay? So let's go back to the code editor. Now, I'm going to right-click on the script folder and select new file, in this case. And then I'm going to set the name of my new file, which is navigate_to_pose.py. Okay? So I have created my new package named Nav2 new features. Inside my package, I have created a new folder named scripts, and inside this scripts folder, I have created a new Python script named NavigateToPose, which, by the way, is empty because I have just created it, right? So the final step is to actually put some code into this script. So again, you can get this code from the notebook, okay? So you have all the code here. So let's select all the code from the NavigateToPose Python script. Let's select all the code from here. Select everything. There we go. Copy. And then paste it here directly to the file which I have opened in my code editor. And voila. Here I have all the code inside my script. Yes? So far, so good. Have you been following? Yes, no? Yes, says Zoltan. Okay, perfect. Patricia, also you? Looking good so far, says Queen Sullivan. Very nice profile picture, by the way, Queen. That looks like a kind of robotic lion, but very nice. Okay, Patricia says yes also. Perfect. Then, what are we going to do? Okay, so now the last step would be to actually test what this code is doing, right? But before that, we are going to have a look at the code, okay? Before executing it and testing it, we are going to actually have a look at this code and try to figure out what it is supposed to do, okay? So for a moment, let's go down to the final section of the notebook, okay? Skip all this where you are testing it, and let's move to section 2.1.2, code review. Okay? So here we are going to have a quick look at the most important parts of the code. So I'm going to open it here myself in the code editor, yeah? So, first of all, we have some we are doing some imports, as always, okay? We are importing RCLPy, which is the client library to use Python with ROS2. And then we are importing, this is very important, from Nav2 Simple Commander Robot Navigator module, we are importing basic navigator and task result. Okay? This is very important because basically basic navigator is what it's going to provide us access to all the simple commander methods. Yeah? And task result, we are also going to be able to use it in order to monitor the result from the NavigateToPose action. Okay? So this is the most important line from the imports. Then, very quickly, we are defining a couple of dictionaries here, right? One is for shelf positions with different shelves and different positions. These are X, Y coordinates, right? And also I have another dictionary for shipping destinations, yeah? Which contains different positions, always in X, Y coordinates, yeah? Then I have my main function, okay? I am setting here a request item location and request destination, which I am assigning some names here. Some names that happen to be keys for the dictionary positions. Okay? Let's keep going. I instantiate an element, an object of the basic navigator. Okay? The basic navigator which I have imported here, I instantiate this into a variable named navigator. Right? I'm going to use then this navigator to call all the methods of the simple commander. Okay? You will see it in a moment. Then, what I am doing here, I am setting an initial pose. Yeah? Initial poses are defined as pose stamped messages. Then I am defining an initial pose for my robot. So I set the frame for this initial pose and I set coordinates. Okay? And once I have defined the coordinates and the frame, then using the navigator variable, as we have just said, I use the first method, which is set initial pose. This is a method of the simple commander. Okay? Then I am using this method in order to set an initial pose for the robot. Okay? This is, you can think of this method as an equivalent to the pose estimate that we used before. You remember? That previously we used the 2D pose estimate here to set the initial pose of the robot. Yes? So this method, this particular method, set initial pose, is used for this, for setting the initial pose of the robot. Okay? Then here I am using another method, which is wait until Nav2 active. Okay? So basically this, what does, as you can see here in the command, is to wait for the navigation system to be fully active. Okay? So basically it's going to make sure that all the navigation systems are ready. Okay? Then, now I am setting shelf item pose. Okay? I am setting a pose here, which I am naming shelf item pose. It's a pose stamped as well for the frame map, for the map frame. And again, I am setting some positions, coordinates for my pose. X, Y, and even orientation. Okay? Then once I have defined my pose, I use another method, which is go-to-pose. Okay? This is the most important method for this demo. The go-to-pose method, it's going to set a goal, which I am passing here as an argument. Oops. I don't know what I have done here. Sorry. Okay, there we go. Yeah? So here we are, yeah? Go to pose method to send the robot to a specific position that you send here as an argument for the method. Yeah? So far so good? Does it make sense? As you can see, it's pretty simple and obvious to understand. Yeah, it's not super complicated code or anything super strange. Yeah? So does it make sense, more or less, so far? Good so far, says Queen. Okay, perfect. All right. Then, what else? So at this point, I am already sending the robot to a pose, right? Then, what am I doing here? Okay, so here I am starting a loop. Yeah, so meanwhile, my robot is going to go to the goal, I am starting a loop here, okay? While not navigator is task complete, yeah? So is task complete, what it's going to check is that if the robot has reached the goal, yeah? Basically it's this. It's going to check if the task has been completed. In this case, the current task is go to a specific pose, okay? So, while the robot has not completed its task, so while the robot has not reached the goal, I'm going to do this. I am calling the get feedback method, yet another method from the Simple Commander. Yeah? This get feedback method, what's going to do basically is to get the feedback from the NavigateToPose action. Yeah? And remember that this feedback contains many information. Yeah? Such as current pose, navigation time, time remaining, number of recoveries, distance remaining, yeah? All this is the feedback of the action. So I am getting the feedback, right? I am getting the feedback of the NavigateToPose action using the get feedback method. And then basically I am printing the feedback, okay? So, for instance, in this case, I am printing the time of arrival. Yeah, as you can see, estimated time of arrival at this location is this, okay? Here I'm just formatting the message. But you can see that what I am printing is from feedback, the estimated time remaining. You see here, estimated time remaining. This estimated time remaining is no other than this variable here, estimated time remaining. Okay? So in this case, I am printing this, but you can print whatever you want from the feedback. All right? So in this case, I'm going to be printing the time remaining, the estimated time remaining, which is the time left until the robot reaches the goal. Okay? In seconds, in this case. I am formatting it to use seconds. Right? Okay, and then finally, I am getting the result from the action. Okay? So once I reach the goal, so once the task is finished, yeah? Once my task is finished, I'm going to get out this while, and then I'm going to get the result. Again, I'm getting the result from the NavigateToPose action. Yeah? So for this, I use the getResult method. Then, if the result is succeeded, yeah? So actions can return different codes. One is succeeded, another is cancelled, another is failed, and there are others, okay? In this case, of course, if the action returns a succeeded, it means that everything has gone okay and that the robot has reached the goal without problems. So if the result is succeeded, what I'm going to do is to define another pose, as you can see here, and call another time the go-to-pose. Yeah? So I'm going to another pose, which is this new pose that I have defined, shipping destination. If my robot has reached the first pose correctly, I'm going to send it to another pose. Okay? If the result from the action is cancelled, then I'm going to send the robot, again using the go-to-pose method, to the initial pose. I'm going to send the robot back to its initial pose. Right? And if the result is failed, then I'm going to exit. Okay? I'm going to exit my program. And that's basically it, okay? So for this new go-to-pose method, as you can see, I am checking again. I am waiting here in this while for the task to be completed, so for the robot to reach the goal, but in this case, I'm doing nothing, okay? In this case, I'm just passing. Yeah, so this is the same that I was doing here, waiting for the task to be completed, but here, in this case, I'm doing some things and I'm getting feedback. In this second case, I'm doing nothing, okay? I'm just passing. Yeah? And that's it, basically. So far, so good. Does it make sense? Do you understand the general structure of the program? Understood, says Queen. Perfect. Perfect. So, okay, just to finish with the explanation, here also, as you can see, at the end, in this notes section, I leave you here a link, okay, to the official Navigation2 documentation. So you can click in this link, and here, you are going to see all the methods of the Simple Commander API. Yeah? So set initial pose, go to pose, the ones that we have been using, is task complete, get feedback. Yeah? So here you can see all the methods that the Simple Commander API provides. Okay? Because here in our program, we have used some of them, but there are many more. Okay? All right, then, yeah, so let's try it out, right? Now it's time to test it out. However, let me, yeah, there is one thing because before trying, there is one thing that we have to take into account. It's the initial pose. So the code, it's going to set a specific initial pose, as you can see, which is around here, okay? My robot is not actually around there right now. So what I'm going to do is to restart everything, okay? Let me just restart everything here by pressing Ctrl+C so that I get back to the initial status. You can also send a goal to move back the robot to the initial position, whatever you prefer. I'm going to just restart everything because it's going to be probably even faster. Yeah, so I restart my simulation, first of all. Yeah, so I am doing this because you need to have the robot in this initial position. Yeah, because this is the position that we are setting in our script here. Okay, otherwise there are going to be issues with Navigation2. Then I start my simulation. I start my Navigation2 system, very important. Yeah, so I should have everything ready. Okay, perfect. And then, yeah, so now let's get back to where we left it. So let's compile our workspace. Okay, let's go to the ROS2 workspace. Let's compile this, call combuild, and let's source, as always. Yeah, so, okay, yeah, so in this case, I don't need to execute this command because I already have it running, okay? Yeah, so this is the command that starts the navigation system, yeah? I already have it running here. So please don't execute it those 2 times, yeah? If you already have it running, don't execute it 1/3 time. So you need to have the simulation in shell number 1, navigation system in shell number 2, and now in shell number 3, after I source, is where I'm going to run my script, okay? I'm going to run it directly with Python 3, as you can see here. So let me just copy the command from here and paste it, okay? And I'm going to execute it right now. There we go. All right, so first of all, the initial pose of the robot should be set here. There you go. So the script has set the initial pose, and now it's sending the robot to its first goal. Yeah? So let's go back to the code. Let's very quickly remember that we set the initial pose first of all, and second, we send the robot to our goal using the go-to-pose method, right? And here we have our robot going to the first goal, okay? And meanwhile it's going, we should get some feedback, right? Remember that we are getting some feedback. So if you go to the shell, you are going to see here that you have feedback, okay? It's not very accurate right now. Probably some errors on the navigation system. Yeah, so the robot here, it's stuck right now. But as soon as it recovers, okay, now it is recovered. So now it should be accurate. Yeah, so now it's accurate again. So 12 seconds, 11, 10, 9, 8, 7. So these are the seconds, as you can see, remaining until the goal is reached. See? 0 seconds. Okay, so I have reached the goal. Then, now it's sending the robot to the second goal. Remember? So I have been printing the feedback, and when first task is completed, I send the robot. So of course, in this case, the action has returned a succeed. So I am sending the robot to the second goal pose, which is this shipping destination. And my robot is going there, okay? It might happen as it is happening to me right now. Sorry. Oops. Yeah, so sometimes it can happen that the robot gets stuck. It kind of stops like this. Don't worry, okay? This is probably because of the limited resources, but if you wait some seconds, the robot should recover by himself, okay? So if we wait some seconds, yeah, there it goes. So now it has recovered by itself. Yeah, and it's going to the goal, okay? Yeah, so here we have it working, all right? So, yeah, basically that's it. This is the demo. Here it's executing some recovery behaviors, as you can see, and rotating and so on. So, so yeah, I'm going to actually stop everything already. Patricia says, all working and understood. Thanks. That's great. That's great, Patricia. This is what we are doing the open classes for, so I'm really happy to read this. I'm really, really happy. So, so yeah, basically that's it. I'm going to leave it here, but before, I always forget this part, but let me do one thing. So, I'm going to, in just 30 seconds, I'm going to enable here a rate form that is going to appear here in the chat. You will see it, so that you can evaluate, you can rate this class. If you liked it, if not, okay? This is very useful for us, so that we can get some feedback from you in order to improve. And there you go. So in some seconds, here you have. So you should see this rate form so that you can rate this class. If you liked it, you can rate it with 4 or 5 stars, and if you didn't like it at all, of course, you can give it 1 star. Okay, I'm going to give it 3 to be there to not affect too much the average. Okay, so and yeah, basically this is all. Let me just remind before closing that we have published right today our new course on ROS2 Navigation Advanced, okay? This is a course that we have published today, as I was saying, and that it covers some more advanced topics that are not covered in the basic one. Yeah, this is the basic one, the one that I introduced at the beginning of the class. And then this course is not covering some more advanced topics like the Simple Commander API is one of them. For instance, how to use map filters, behavior trees, plugins in Navigation2. So all this more advanced stuff is covered in this course. Yeah, and of course, it also contains all the Simple Commander API theory, including things that we have not covered in this class, like the go through poses action, follow waypoints actions, etc. Okay, so yeah, I just leave the link here in case you are interested. You can have a look. Very interesting course, and yeah, so I'm going to leave it right here. Thanks to all of you for being here with me. Thanks also Hadi, Fergmandi, and Zoltan for your messages. Thank you very much. And yeah, I hope you enjoyed it. I hope you have learned something interesting today. And as always, I will see you again next Tuesday with the next open class. And until then, take care and keep pushing your ROS learning. Bye-bye.